All right, let's see. We are right about um, here. Right? Um, so we've been using the mean stack with the latest version of Angular 4, um, and we've gone through implementing various versions of our prototype. First as a static HTML uh, um, proof of concept, right? That we might use to show our clients for eliciting some feedback. Then we went through adding JavaScript and Angular 4 and jQuery to make our application dynamically generated and render on the client side, on the browser side. Then we added a server side, and we moved a lot of the hard-coded data that we were hosting on the client side. We moved it over to the server. And finally, last couple of weeks, we've been moving the data where it belongs in a MongoDB database for permanent storage. We did implement some logging in and registration and authentication, authorization from all throughout the proof of concept, but it's not really the way you would implement authentication and authorization and securing websites. Currently, if you know somebody's ID, you can certainly navigate to their profile page and take over their account. Right? Also the requests going back and forth are in the clear. Right? The text, right? The data that's being transmitted between the client, the browser, and the server is in clear text. Right? So we also, the data that we're storing in the database, their username, password, some of the sensitive information, we're storing it also in the clear in the database. So we need to revisit our strategy for protecting our application, for securing application, make sure that we don't have any unauthorized use of resources. Okay. So for that, we're going to be introducing Passport.js. So for the next couple of weeks, we're going to be securing our website so that data is not transferred in clear text between the client and the server. We're storing passwords securely in the database so that even if you're an admin, no one can actually know what the password is. Right? There's no way for somebody to impersonate you. And also, we want to be able to secure certain data that is encoded in the URL. Right now, the user ID is encoded in the URL. Okay, we'd like to fix that, right? So that any information that is known about the identity of the person, right, is only known on the server side, right? Never made public, never encoded anywhere on the client side, right? It would always be on the server side that all this identifiable information would ever exist. Okay. So for the next couple of weeks, that's going to be our focus. And for that, we also have an assignment, our last assignment that I would like to go over. Now, securing mean stack applications or single page applications in general is a little more involved than securing server-side applications. In server-side applications, if you're using PHP or JSP or any server-side rendering mechanism, the protecting the navigation that going to a protected area in the application is a little simpler, right? You just need to protect the URL, right, so that folks can't navigate to a particular URL unless they are authenticated. Yes. Here, not only do we have to do that, certainly we have to do that, right? Protect that you can't navigate, but there's also quite a few other things that we need to protect that you wouldn't have to protect on a server-side application. In a server-side application, all the data access is done on the server side, right? The page is rendered on the server side, and as the page is rendering, it's also accessing data on the database, right? So the rendering happens also in the same location on the same CPU and process, and that is can also access the database. Yes. Okay. In single page applications, the rendering of the page no longer happens on the server. Yes, it happens on the client side. The client needs access to the data, needs to go back to the server to retrieve the data. Yes, so we need to not only protect the navigation, we also have to protect the accessibility of all that data. All that data no longer is only accessible only on the server, is being made public, right, to anyone who wants to access it by using gets and puts and posts and deletes, right, through URL endpoints. Yes. So those also need to be protected, right? To make sure that if somebody's making a get, that they're authenticated, that they're privy to that information, that they should be able to read that information. Make sure that that is also protected. So it's a two-step process, not only protecting navigation, but also we need to protect all the APIs, right? All the URLs that retrieve data, that post data, that delete data, that get that put data. Okay. So for that, we'll be focusing the next couple of weeks. And also we'll be introducing the capability of being able to use third-party authentication authorities, right? Today we'll take a look at authenticating through just local database. So we are going to be use our own database to keep track of users that have registered with us. Yes. That have provided an account information, first name, last name, username, password with our database. Yes, we're going to be authenticating against our own local database. But we would like to allow folks to, if they already have an account on several other websites, we don't want to have to force them to create yet another account with us. Right? If they already have an account on Google or Facebook or Twitter or whatever, right? We can allow them to use their account, right, as an already registered user, and so that we can authenticate against these other third-party authenticators, right, and ask them, hey, is this a valid user? Then come back to me and say, okay, well, I'll log you in as that user. So today we'll take a look at the local strategy, and next week we'll take a look at Google and Facebook. All right, so let's take a look at the assignment first, and then we can start.